All right, cool kids. Thank you so much. Thank you so much. Let's get going then. Joel, you good? Law of signs. Help me out real fast. Does it matter which orientation of the formulas, kiddos, that we're using?
No.
Okay. What was my hint? What's with these little circly things? My personal opinion as to what was easiest?
Put the unknown.
Put the unknown on top. It's just the simplest way to solve algebraically, right? So if you're missing who's this guy? Who is a side? So if you're missing a side, I would do sides on top. If you're missing an angle, I would do angle on top. But let's see if we can dig a little deeper, okay? When we look at these three cases, what's the only one where we're going to actually be missing an angle that we need to use this law for? Okay, let's reword it one more time. What am I asking? Which of these needs us to use the law of sines to find an angle? Why would I say not this one? Let's just do process of elimination.
There's 2 A's.
Because it has 2 A's, well, why is that a good thing in a triangle? If you have 2 of them, you can always find that. Because all the angles add up to be
180.
and even non-right triangles, right? They all add up to be 180. So if I have 2, I'm golden. So what does that mean about this guy?
You're golden.
I'm golden, right? Solve for the third, 180 minus. No big deal. Right? Okay, remember SSA, the one from geometry, couldn't prove congruence. Like you guys were totally not allowed to use them ever, and there's a way of remembering that. But in pre-cal, we're still dealing with him. So, question, how hard was it to use law of signs on this guy on Friday? Well, how was it? Yeah, you guys liked this example. You were like, sweet, get it in the law of signs. Move to the other side, calculator work, right?
Yeah.
Make sure you're in degree mode, but otherwise solve, we're done. How bad was this one? This is the other case, ASA. Yeah, use 180 minus to get the third angle, and then we just set up and solve. So, what was weird with this guy? He's the ambiguous case, I call him the painful case.
Side angle.
Okay, side angle. If we're thinking carefully, that should jump out of this being like, oh wait, that's weird, that's wrong, that's off. But second of all, what was different when we plugged into the law of signs? Could we just multiply to the other side and be done? Because we had sine of A equaling this value, right? So what did we have to do to get to angle A? Yeah, we had to do sine inverse, right? We had to use that inverse trick. We had to undo the sine from both sides. Now, we didn't fully get to see why I wrote this whole case 2 thing on Friday. All we heard was, you know what, 0, 1, 2, there's some ambiguity as to what's going to be true when you start plugging in with SSA. We talked about the sine inverse. Okay, that's no big deal. Undo the sine, and we were able to solve. It was weird. There's just a really tiny angle, but we solved, and it was done. Then I said, you know what, tricky. With sine inverse, we got to check this other case. Can anybody tell or remember, it's been a while, it's been a weekend, why I had to cross off this case? First of all, let me tell you what I did. Then I want you to be thinking of, why did I cross off this case and say it wasn't even possible? Meaning, automatically, this is in the camp of only one possible solution. Why did I cross off this case? Let me remind you why I even started over there. Sine inverse. This is a big question. Sine inverse. We talked about it for a long time back in chapter 4. Sine inverse. Are there restrictions to what the calculator spits out as far as what quadrant it looks at for sine inverse? Yes. It doesn't look at quadrants 1, 2, 3, and 4. Does anyone remember which quadrants it looks in when you plug the second sine into your calculator? Quadrants 2. It's actually not quadrant 2. Every inverse trig always starts looking in quadrant 1 for any positive trig ratio, sine inverse, cosine inverse, tangent inverse. Looks in quadrant 1, so those are the normal negating angles, 0 to 90. What if the sine was negative? Would it go to quadrant 2? Is sine negative in quadrant 2? No, sine is positive. Where is sine negative? Quadrant. Oh, it is negative in quadrant 3, but it would have to go all the way and skip to quadrant 3. Quadrant 4, good. So sine inverse naturally looks at negative 90 to 90, quadrant 4 and quadrant 1. Negative pi over 2 to pi over 2. Okay, so, you guys, it was not that stressful. Sine inverse only looks here and here. Here's my question to you. If sine inverse only looks here and here, What are the only angles that would make sense to be in some random geometry triangle? Would quadrant 1 angles make sense to be in a triangle?
Yes.
Yeah, 0 to 90, no big deal. Would these angles, negative, or 0 to negative 90, would those make sense in a triangle?
Not really.
Not like a geometry triangle. Not a triangle that's not in like an XY plane. So these ones don't make sense, first of all. So we're not even going to have to deal with those. This quadrant makes sense, and sine inverse solves for that. But question, are there any other angles that could be in a triangle besides 0 to 90? What other angles could show up in a triangle besides just 0 to 90?
180.
I don't know if 180 could be in a triangle, because he has all the 180 in him, but you're close. 30, 60, 45, those should all be in the first quadrant. Are there any other angles besides 0 to 90 that can show up in a triangle? Yeah, what about 120 or 110 or 105 or 140? Can we have an obtuse triangle? Yeah, of course we can. We can have an acute one, but we can also have an obtuse one. So what poor quadrant hasn't even been looked in yet? Well, quadrant 3 would be like 190. That's too big for a triangle. So what quadrant do I need? Quadrant 2. Is sine inverse going to get me there? No. He's only looking in quadrant 1. So I need to look and say, wait. We have to consider, hey, 180 minus, guess what quadrant I'm getting to? I'm saying, hey, could have been an obtuse angle. It's not a right triangle anymore, so I could have an obtuse angle, right? So, using sine inverse, case 1 lets me look in the first quadrant. Using case 2 lets me look in the second quadrant and say, are you possible or not? How do I do it? I take the sine inverse that we found in case 1, and the sine inverse got us angle A to be 1.819. And I say, okay, cool. Well, if 1.819 is a possibility, guess what? I want the second quadrant equivalent of that, which I can find by doing 180 minus sine inverse. But kiddos, once I found that 178.180, why on earth did I say, nope, it's not possible this time, and I crossed it out? Why did I do that? Why couldn't it have been 178.180? I'll go check the errors you guys are finding. Chris thinks he has an idea. The rest of you guys take a second and look. Why couldn't it have been 178? Why couldn't angle A have been 178.180? Chris, go ahead. What do you see?
What if you add it with angle B, it would be over 180?
Angle B, is that something they gave me that I know must be true?
Yes.
Kiddos, what's the measure of angle B? I turn the arrow. 2 point something. What's 2 point something plus 178 point something? More than 180. Is it legal to have more than 180 in a triangle? No, and it doesn't even leave room for a third angle. I can't even have a third angle. So could this join with that and another guy? No. So we're always going to, with SSA, with the ambiguous case, with when we have to use sine inverse to solve, we're going to check sine inverse for quadrant 1 and check 180 minus sine inverse for quadrant 2. There is a cool, I don't know if it's cool, but there's a huge old table in the book that I think 1 or 2 homework problems has you look at as to when, for SSA, when you're going to have only 1 or 2 or none. But let me actually just show you some of the math as to how you can see them, and then we'll go back and look at the table again. You don't have to memorize the table. You don't even specifically have to use the table. It could be helpful for some of you that are super visual. So I'll try to help with that. But let's do another example and see if we can figure out, okay, we just saw a case where there was only one possible. We went looking for quadrant 2. We went looking for obtuse angles. And that wasn't possible. So I want you guys to say, okay, hold on, law of science. We were liking it on Friday. What did we do? Take these pieces of information and plug them into law of science how you would need to in order to solve for what's missing. So get your picture, get your example, and then start to plug into law of science. If you don't have your calculator out, grab that out too, because we're going to be using them just like we were in section 6.1, part 1. So you have angle A with side A. I think that's a pair to plug in. You have side B, but you're missing angle B. Who you guys solving for first? Yeah, angle B, right?
Yes.
Good. Problem is, angle B is inside a sine, true? So to solve for him, not only do you have to get sine of B alone, you have to get B alone also. Keep going, plug it in. Let me try to put it in there. You guys get why I set it up like that? Here's my unknown, angle B. So I put him on top. This makes it easier. Because I only need to do one thing to get sine of B alone. What's my next step? Good, multiply. Get rid of that division. Now, here's where we go, our case 1, case 2. As soon as you, in log sine, start taking sine inverse, you gotta think, uh-oh, hold on, that's only one way of solving. One way of solving for side, I should say, sorry, angle B, is to take sine inverse of that whole other side. 12 sine of 42 all over 22. That's one way. That's me just looking in the first quadrant and saying, okay, I think he's an acute angle, or he could be an acute angle, so let's try it. Make sure, once again, if you weren't using your calculators on Friday, you have to be in degree mode, yeah? What did you guys get for angle B? Okay. You guys agree with landing on 21.406? Now, we are going to keep solving. We could technically find angle C right now, because once we know, well, we were given angle A, and now we found angle B, can we look for angle C? The answer is yeah. Okay, we can do that fast. 180 minus the guy I just found, minus the 42 degrees to begin with. Double check me, guys. 116.594. Bless you. Now, we still are missing, I think, side C, but hold on, pause. That was us assuming that the missing angle was acute, assuming it was in the first quadrant. Gotta be careful of assuming though, right? So case 2 says, don't just take sine inverse at both sides. Don't just look in the first quadrant. How can I look anywhere else? What'd you guys write down from the page before? How do I look in the second quadrant? Uh-oh. If you're a highlighting kind of person, a starring kind of person, a colored pen makes me study things kind of person, I would go back right here, and I would highlight case 1 uses just sine inverse. Case 1 uses just sine inverse, aka it just looks in quadrant 1. Case 2 needs 180 minus sine inverse. So ambiguous case, SSA, case 1, we just do sine inverse and go with it. Case 2 says, nah, we gotta look in second quadrant. And the way to do that is 180 minus. Use that symmetry. If we have an angle here, we can find its associated angle in a second quadrant just by taking 180 and taking away that original angle. So case 1, sine inverse and go. Case 2, 180 minus sine inverse. So let's see if we can answer a little better. How am I going to find the other option for angle B?
180 minus sine inverse.
Exactly. And, I mean, I guess you could write the whole thing over again, but you could just say, wait a minute, I just found that guy, so can't I just do 180 minus that guy?
Yeah.
So 180 minus the 21.40637223.
158.593. 594.
Yeah, I agree. Now, here's how we're gonna know whether or not it's an option, whether or not to cancel it out. Or to cross it out and say, nah, it's impossible. When we go look for the third angle, let's just see if it's possible or not. So how are we gonna look for angle C?
180 minus sine inverse.
The same way I did before. Well, not minus sine inverse, that's how we found this guy. How am I gonna find the third angle in the triangle? 180, good, minus the 158, and also minus the 42. But when you go subtracting, why is it bad that I got a negative 20.594? You can't have a negative, look at it, this guy and that guy were over 180. So there was another illegal second case, meaning these three pieces of information will only give me how many triangles?
One.
So now we've seen two different ones that give us just one option. Let me show you kind of visually how this one option happens. Well, hold on, wait a minute, we still have one more piece of information to find, right? Who are we missing?
Side C,
Okay, so how are we gonna solve for it?
A over sine of A.
Yeah,
Or
we can use this guy because he's the next pair, right? So we have 22 over sine of 42, using A over sine of A equals, and I need C. Can you guys tell why Michael changed the orientation? Why did he change with the sides on top? The side was missing, right? So I need to go ahead and plug in my sine of, who's his corresponding guy?
116.594.
Now, why am I gonna put 0.593 dot dot dot? I don't want you to round it when you plug in. Round it for the final answer, which we have right here. Final answer, it's rounded. Final answer, it's rounded. When you plug it in to solve for somebody else, though, don't round it. You guys hopefully see that you're supposed to multiply to the other side, right? Pop them over. So I have 22 sine of the 116, go find the big old long guy. 116.593, 6278, divided by sine of 42. Anybody else get 29.400?
Yes.
Guess we didn't need three of those. And for those of you that I lost with the math, remember I'm just multiplying this big old sine of 116 to one side. I'm multiplying him 116.593 to the other side. C is a 1. Plug it in your calculator, that's the one side. Now, let me show you something. Okay, what if we were to take this very example? 42 degrees, 12 inches, and then the 22 inches. And let me change up this problem just a little bit. Let's try to figure out how could we get two cases possible? Or even how could we get no cases possible? All we've seen so far is there's only one possible way of doing this information. What if I was to give all of you guys protractors, okay? Which would take a little bit of time. That's more of a geometry thing. Let's say I was to give you all protractors. And I was to say, okay, I want you guys to measure 42. There we go. I want you to measure 42 degrees. Where is he? Right there? Okay. All right, so I have 42 degrees. And then let's say I wanted you guys to get out a ruler. And let's say I wanted you to measure, what do we got, 12 inches? Let's measure 12 inches. So we'll go ahead and do this. So I gave you like a piece of string. Actually, pieces of string are kind of movable. Let's just say I gave you a stick or some sort of piece of wood that was like 12 inches long. About 12 inches? Centimeters. Inches would be way too long. Let's do centimeters. Okay, that's pretty close, right? The 22 in the last problem, this 22 made it so that there was only one case. So I want us to think about, okay, what would it take if I knew that angle A was 42 degrees and side side C is 12 inches. So here's our little 12 inches. and here's our angle A. Let's think about what they could give us for the third side. We're trying to think of, okay, well, what would have been a side A that would give us more than just one option? Guys, since this is side C, do you know where he has to go? Can I put side C, for instance, over on like this side of the triangle? Is that possible?
No.
No, because that needs to be angle or side A, right?
Yes.
Could I put side C down here?
Yes.
I guess I could, but don't we normally go A, then B, then C? So wouldn't B be this guy up here?
Yes.
So because of that, let me go ahead and put this side C over here. So that way it's kind of similar to what we just saw in the sense of, we make it line up all nice and neat. A was this one. Oh, C was that one?
Yes.
Oh, that's no fun. Okay, let me change the letter then. Let's make this side B. That way it's like the other one. We'll make it side B so it looks like the other one that you guys just drew. Okay. Now, question. Have I told you how long this needs to be?
No.
Have I told you how long that needs to be?
No.
Okay. So those are still up in the air. Those are still unknowns. What would be a side? 22 didn't work. 22 got us only one case. And remember, 22 is longer than 12, right?
Yes.
So 22 would have had to be 12 and plus a little more. And there was only one way to make a triangle if they gave us 22. Okay, give me something else. Guess higher, guess lower.
7.
7. Okay. So if we were to do 7, let's say I was to give you a stick and be like, hey, can 7 make a possible triangle? You used to that from geometry. Possible triangles or not possible triangles. So what if they gave us 7? Let me go ahead and measure that. Okay. How can we know whether or not this 7 is going to give us a possible triangle? Let's go take them down and let's try to make a triangle. This is 7. The shortest distance between any 2 points is a... Let's not tilt him yet. Let's just see if he can connect it all. Can he connect it all?
No.
So why is 7 too short? Because it is. Well, mathematically, how can we figure out how short the third side can be? Kiddos, what kind of triangle would this make if it went straight down? Okay. So let's pretend this is a right triangle. Let's say, well, what if it is a right triangle? If it is a right triangle and this is 12 and this is 42, can't we figure out the very shortest that side can be? Just by using, hold on, help me out. What trig would we use if we have hypotenuse and we're missing?
Opposite.
So what trig?
Sine.
Good. So someone help me out with your calculator. Sine of 42 equals x over 12. What does 12 times sine of 42 equal? What do you got, Ruth?
8.03.
Okay, you guys agree?
8.03.
Oh, because then we round up the 9. Okay, so 8-ish, right? 8-ish? So what else couldn't A be? Well, anything less than this guy, right? So right now I know that in order for A to be legal, or I should say, in order for, this is SSA, this is our ambiguous case. And our ambiguous case has how many different options? 0 solutions. When would it be a 0 solution? If they gave us A is less than 8.03. If they told us that A was 7, or 6, or 5, or 4, or 3, or 2, or 1, it's not going to work. There are going to be no possible solutions at all because 8.029, et cetera, is the very shortest that side can be just to connect straight. So 0 solutions, they're going to give me something smaller than that. Now, we just talked about one solution a few times. Do you guys see if it was 8.03, that there would be just one solution? Or I should say 8.029. Let me just put 12 sine of 42. Why would there be only one way to connect, even if I did have it perfectly long? Is there any other way to make a triangle than just to connect it right here where it skims? Can I tilt that stick at all and have it still make a triangle? Mm-mm. So if it is that 12 sine of 42 or that 8.029, there's only one way that's going to connect. It skims, it hits right here at a 90 degree. Okay? But what if I was to go just a little bit above 8? Pick something just a little bit above 8, but less than 12.
8.1.
10. Okay, maybe something a little bigger than 8 that I can like measure on here. 10.
10 and a half.
10 and a half. You guys are getting complicated. How about just 10? So let's say we did 10. That's bigger than 8, but less than 12, right? Okay. Let's figure out if this is like a 1 solution or if this is a 2 solution. Type case. We actually haven't seen that one yet. Okay. So I'm going to take this guy. Let's make a triangle out of it. Can I go straight down? No, it's going to be way too long. Right? So what am I going to have to do?
Tilt.
What do you guys think of tilting? Out?
Yeah.
Okay. So I need to tilt out more, right? Oh, too much. Pretty close? No. You think?
Not quite.
Ah, struggle a little bit less. That's the same.
let's do it again.
No.
Just try moving it.
Not good.
I think that's pretty good.
Perfect.
Shh, we'll just take it. Okay, so can it make? I'll just make that. Okay, that looks good. Can that make a triangle? So 42, 12, and then 10. But why am I going to say that anything with A greater than 8.029 but less than 12 is going to be 2 solutions? How is there a way to make another triangle besides this one? Can I tilt it out anymore? No. Disconnects. But what if Joe's saying why don't we angle it in instead of angling it out?
Oh.
Huh. Can I angle it in?
Do it.
Is that a triangle?
Yeah.
So what's the struggle? If they just give you SSA, sometimes for third sides, or I should say the third piece of information, sometimes for the opposite side from the angle, sometimes it's not enough to know exactly which triangle they want. Whenever that opposite side is greater than the right triangle side would be, greater than the opposite side would be if it was a right angle, but less than this side, you could swing it out and make one, or you could swing it in. So this would be an example where we would try our 2 cases, and not only would that one work, but that one would work also. Not only would this one work where all my angles are acute, but this one would work also where I would have an obtuse angle. So that begs the question, hold on, wait a minute, what was wrong with 22 then? Why didn't he have 2 options? We've talked about if it's less than the opposite of a right triangle, well forget it, it's not going to be possible. We've talked about if it is a right triangle, well it can only hit in one place. We've talked about, well what if it's bigger than the right triangle opposite, but it's less than, well we can swing it back or forth. So let's talk about that 22 again. Well actually let's talk about something bigger than 12, but not 22 because my ruler only goes to 15. How about 15? That sound good? What's wrong with 15? Why can't we do this nifty 2-case thing for him? You guys can probably tell. Can I swing this guy out?
It's too long.
Well, I can keep him going. But can I swing him out? Yeah, the 15 I can swing out, no big deal. Here's the question. Joe, can I swing him back?
No.
Because your idea? Why can't I swing it back?
Oh.
I agree with you. Yeah. Isn't the 15 longer than the 12?
Yeah.
So what if I tried to swing it back?
False.
If I tried, the only way to get him to connect would be to go past the 12, but what did I just lose as I swung back? I lost my 42. So why is SSA never to be used for congruence in geometry? Because he's ambiguous. Sometimes he points to 0 answers, sometimes he points to 2 different possible answers, or 2 different possible triangles. But every now and then, he does just point to 1. But A either has to be the opposite of a right triangle, or it needs to be greater than the side that is given, the other side that is given. Now kiddos, this is what that big old table is trying to show you. The big old table is trying to say, hey, sometimes that opposite side is just too short, so that's going to be a none. Sometimes that opposite side forms a perfect right angle. Well, that's only going to be 1 because it can't connect any other way. It'll be too short unless or except for that one place. Sometimes, if A is bigger than that side, it will still only connect in one place because it's too big to swing back. But if A is in between the H and the B, it can swing both directions and have 2. Now it talks about a couple other things as well, but basically these are the main 4 cases as to what can happen. Do some of you visually see it? I hope so. But ultimately, we got to make sure that, well, there's a formula and we're supposed to be plugging into it. So how do we know what's what? Well, okay, let's try this guy. Let's try this guy. How do we know what's what? If we're just going along solving triangles, not really thinking about is there an SSA or not? Or an ASS is what this one is in order. What if we're just not thinking about it? What if we're just plugging in? Well, first of all, how do we know to be on the lookout? We got to put an angle up top because we're missing them. We know to be on the lookout whenever an angle is unknown. Got to be on the lookout whenever an angle is unknown. When the angle is unknown, we can still set up the law of sines and we can still solve. But when we solve, we're not going to have B alone. We're going to have sine of B, which should, hopefully, remind us that we need to use sine inverse, right?
Yes.
And when we use sine inverse, we have to say, wait, weird sine inverse, there's something special about him. That's right, sine inverse only looks for little acute angles. So we're going to take sine inverse of both sides in order to find B. But we have to remember, every time there's an SSA, unless we want to draw all those pictures and try to figure out visually whether or not it works to make 0 or 1 or 2, mathematically we just have to say, all right, hold on, no big deal. Just check the 180 minus also. Check the sine inverse, but check the 180 minus also. Both of these are for the angle that we're trying to find. When you plug in the sine inverse to your calculator, anybody beat me there yet? Oh, why? 20 sine of 76 all over 18, but we're trying to take sine inverse of that. So anybody figure out that that actually ended up being 1.07 that we were trying to take sine inverse of? So if we try to do this, our calculator says error, so guess what it's going to say when I try to do 180 minus error? Kiddos, the math or the formula helps us because the math or the formula is going to tell us when there's no possible triangle because there's going to be an error. So no solution, or you could say not possible triangle. That's kind of a geometry way of us saying it. It's not a possible triangle. So the formula is going to help. The nice thing is that we've gotten to see when only 1 is possible, because the case 2 doesn't work. We've gotten to see when none are possible, because that's when neither case works. So in homework, let's see if you can find anywhere 2 are possible. Where this one works, you got to figure it out and finish. And this one works, so like, all right, it's one of those weird swinging back in triangles. Now, kiddos, before you leave, because we still have 30 seconds, let me show you the one page we didn't get to. The one page we didn't get to says, hey, if they ask us to find area of a triangle, it's easy, 1/2 base times height, but, if it's not a right triangle, do we know the height?
No, we don't.
Not without a lot more trig. So guess what we can kind of cheat and use?
Trig.
This spiffy formula that says as long as you have side, angle, side, you can plug in the 2 sides and sine of the included angle, and guess what your area is gonna equal? That guy. If I were you, I'd take a picture on the way out the door, because you're probably gonna have to use them in homework tonight. Otherwise, they'll be up on the board first thing tomorrow if you still need to copy them in your notes. But it's just an area formula. Plug and check, no big dealio. Cool kids, this homework due tomorrow. Thanks for the extra 20 seconds. It's time for chocolate. See you guys later.